Let's take a look at another linear application. An airplane begins descending towards Philadelphia International Airport. After 5 minutes of descent, the altimeter reads 3,400 meters. At 12 minutes, the altitude of the plane is 2,000 meters. Let x be the number of minutes of descent and y be the meters from the ground. So just to make sure everybody's clear, altitude is the distance between the ground and the plane, and the altimeter is the instrument that shows the pilot the altitude. Let's go through this problem. It's broken down into several sub-questions. First, part A, we want to write the information above as two ordered pairs. We were told to let the input be the number of minutes and the output be the meters from the ground. So after 5 minutes of descent, the altimeter reads 3,400 meters. So one of our ordered pairs is 5, 3,400. And then at 12 minutes, the altitude of the plane is 2,000 meters. So this one is 12, 2,000. So we have two ordered pairs representing the altitude of the plane at two specific times. We want to now find the slope of the line between these 2 points. Give the meaning of the slope in the context of this situation. We know that the slope is the change in the y values over the change in the x values. And to measure those change, we can do y2 minus y1 over x2 minus x1. So we need to subtract the y values. Let's do 2,000 minus 3,400. And once you've decided which direction you're subtracting the y values in, you have to subtract the x values in the same direction. So we did 2,000 minus 3,400, so we need to do 12 minus 5. So we've got 12 minus 5 in the denominator, and now let's do this arithmetic. We've got negative 1,400 in the numerator, 12 minus 5 is 7 in the denominator. Negative 1,400 divided by 7 is negative 200. So the slope of the line is negative 200. But we also want to give the meaning of the slope in the context of the situation. Well, what were our y values again? They were the altitudes measured in meters. So we've got meters per, the x values was the time measured in minutes. So meters per minute. That's the meaning of this negative 200. And specifically, the reason it's negative is because the plane is descending. So the plane is descending at a rate of 200 meters per minute. That is the meaning of the slope. Let's now write an equation representing the relationship between the number of minutes of descent and the meters from the ground. Well, it is a linear equation that we're looking for, so we can work off of y equals mx plus b. We need to determine both m and b. Well, we just found m. The slope is negative 200, so we can put that information in. We've got y equals negative 200 times x plus b. To find b, we will temporarily plug in one of these two ordered pairs. Let's go ahead with this one here. So we've got 2,000 for y equals negative 200 times the x value there is 12 plus b. And now we have an equation just with b in it. We can solve for b. We've got 2,000 equals negative 200 times 12 is negative 2,400. And then, of course, the plus b. And if you add 2,400 to both sides, you get 4,400 is equal to b. So the equation of the line is y equals, the slope was negative 200 times the input variable x plus the y-coordinate of the y-intercept is 4,400. Let's now answer a couple of additional questions about this plane's descent. Let's find the y-intercept and say what the meaning of the y-intercept is in the context of the application. And again, we just came up with the rule is y equals negative 200x plus 4,400. Well, for the y-intercept, we don't need to do much of any work. Remember, the b value, when the equation is in y equals mx plus b form, is the y-coordinate of the y-intercept. So again, the y-intercept is not just that number. The y-intercept is an ordered pair, and its x value is 0. So it's 0, 4,400. That is the y-intercept, but what does it mean with respect to this application? Well, this 0 is the number of minutes since it's been descending, and the 4,400 is the altitude. So essentially what this means is the plane is at an altitude of 4,400 meters when it starts to descend. So the plane is at an altitude of 4,400 meters when it starts its descent. This is the y-intercept of the line, and this is the meaning of the y-intercept for the plane. Let's now find the x-intercept. And again, we also want to say what the meaning is of that point. The x-intercept is not conveniently placed right in the y equals mx plus b form. We actually have to work for that. So we know an x-intercept has a y-coordinate of 0 because it's the point where the line crosses the x-axis. So we're going to take our equation and plug in 0 for y. And we get 0 equals negative 200 times x plus 4,400. And now we can solve our equation and get the x-coordinate of the x-intercept. So let's simply add 200x to both sides so I don't have to deal with that negative coefficient. And we get 200x equals 4,400. And then if you divide both sides by 200, we get x equals 22. So that is not the x-intercept. Remember, the x-intercept is an ordered pair. And we got that x value of 22 when the y-coordinate was let to be 0. This is the x-intercept. What is the meaning of the x-intercept? Well, this is a number of minutes, and this is an altitude. So basically what it's saying is it takes 22 minutes to get to an altitude of 0, which means the plane landed. So it takes 22 minutes for the plane to land. We found the x-intercept, and this is the meaning of the x-intercept with respect to the plane.